In order to use a webcam for night shots for astronomical purposes, we purchased a Spinel UC20 MPE sensor with a nominal sensitivity of 0.001 lux. This sensor turned out to be extremely performant, succeeding to capture stars invisible to the naked eye with a small, wide-angle standard objective. In order to use this sensor even for deep sky shots, we have developed software that allows the sum of multiple frames in real time, so as to extend the limited exposure time normally allowed by this type of sensors. This sensor in particular has the unusual ability to reach up to 1 second of exposure, whereas normal webcams typically reach a maximum of 1/10 of a second. The aforementioned software, called Webcam Extender, is therefore expressly designed to be able to extend this limited display capacity, thus making it possible to capture objects that are normally invisible in normal filming using standard capturing softwares. Obviously, given that our interest is purely astronomical, we have created an adaptation that allows us to use photographic lenses with a standard Nikon mount with a UC20 MPE, so as to enable the use of more performant lenses than the standard wide-angle lens that came with the sensor itself. On the evening of August 9, 2019, we were preparing to test a newly purchased objective, a Nikon 85mm f2, to indeed verify its optical quality and accurately determine its performance, in conjunction with the Spinel's UC20 MPE sensor. Given the focal length of the lens, we immediately realized that without any equatorial tracking, summing more than 2 frames with our software was not convenient, a problem that fixes as soon as we adapt it to a motorized equatorial mount. The first results were immediately very exciting. On the monitor it was already possible to see stars of the 8th magnitude real time, despite the presence of the moon in a sky that was not completely clear. We made the first tests by pointing the moon itself and Jupiter, of which it was already possible to see at least 2 moons. Our moon appeared large enough to be able to appreciate some visible craters on the terminator. As soon as the sky became dark enough and the moon itself approached sunset, we began to capture the first stars, starting from the constellation of Lyrae, which was very close to the zenith by that time. Wondering, at the number of visible stars and the Epsilon Lyrae perfectly resolved into 2 clearly separated stars. Suddenly, around 11:28 p.m., we noticed the presence of an object that moved between the stars in an easterly direction. Enthused by enthusiasm, we immediately started recording, succeeding in capturing 50 usable frames of the latter. Further attempts to reposition the object after leaving the field of view have unfortunately failed. Each frame is the sum of 2 frames of 1 second exposure each, which, therefore, make the duration of a single frame in the final recording 2 seconds. The sequence where the object is recorded, thus, lasts 100 seconds. The object was invisible to the naked eye and showed in the images taken as a singular shape consisting of 2 blue luminous points, joined by an arc of light, also bluish in color, but less luminous than the 2 points themselves. The apparent motion was extremely slow and therefore definitely not attributable to an airplane, which also would have had to blink. The direction and angular velocity are more typical of a satellite in a medium-low orbit, but the aspect definitely does not match this hypothesis. Furthermore, at the moment, none of the known satellites were flying over Amsterdam. Using an image stacking processor program for astronomical purposes called Registax, we stacked all 50 frames following 2 different processing lines. In the first case, we stacked the frames, keeping the stars aligned, so that we could accurately identify the area of sky that we had captured. This turned out to be just below Vega, at the same height as Zeta Lyrae, which in fact appears in the latest frames as the brightest red star that enters the field of view from the left side. In this elaboration, it is even possible to see stars around the 9th magnitude. In the second elaboration, stacking was carried out following the object itself, in order to improve the object's image quality to the maximum and be able to study it in more detail. The doubt was that, by increasing the visibility of invisible dark details in the individual frames, we could better observe its morphology and maybe even be able to identify it. Unfortunately, despite the quality of the processing thus obtained, we have not been able to associate its shape with anything we know. We can only surely say that the unidentified object's singular shape resulted into two luminous arches that joined the 2 points of light, of which the one farther east was definitely the brightest, all forming a sort of a singular old telephone handset. In conclusion, it was impossible to identify the object itself, whose nature at the moment remains unknown to us. Hence, given the peculiar nature of such a phenomena, we have decided to publish the material at our disposal for the benefit of anyone who wants to see it or is even able to explain its nature. If you wish to learn more about the matter, we have written a full article about the latter, with more precise data and in-depth technical analysis, which you can find visiting my website, namely mattiapeiretti.com, or clicking on the direct link below.